Below are all the steps for performing a hypothesis test when sigma is known. I'm going to do an example of performing the hypothesis test step by step. Then we'll use the chart at the bottom to decide how to word our results. We have to make a decision about the null first, and then we want to make a conclusion about the claim. Here's the example. An office supply company claims that the toner cartridges they sell will last for 10,000 copies. A sample of 25 cartridges shows the average number of copies is 9,971. We know that the toner lifespan is normally distributed with a population standard deviation of 122 copies. Test the company's claim at the significance level of alpha equals 0.01, which is 1%. So let's start with the first step. We want to verify that we actually can use the hypothesis test in this situation. According to the steps, we have to verify that sigma is known and that the sample is random, and we have to have an original population distribution that is normal or a sample size at least 30. Do we have that in our situation? The population standard deviation is given. Sigma is 122. Is the population normally distributed? Yes, they said it was. So it is valid to use this approach for the hypothesis test. The wording's a little tricky here. It says the office supply company claims toner cartridges they sell will last for 10,000 copies. So the way that I interpret that is the mu will be at least 10,000. That's their claim. If it lasts longer than 10,000, then both the company and the consumer are going to be happy with that situation. If the toner dies at 10,000 copies, then that would be fine as well. They told the truth about what they advertised. Does the claim include equals? If yes, then HO is the claim. If not, then HA is the claim. Let's write the null and alternative hypotheses. Our claim does include an equals sign, so we want to make that HO. Now we have to write the complement, which is the opposite, that it's less than 10,000. Okay, we're going to assume that the null hypothesis is true for the purposes of the test. Now let's determine the significance level that was given in the problem. Alpha equals 1%. Should we do a left tail, right tail, or two-tailed test? This all depends on what type of null was written. When we mark our curve with a boundary, the shaded area is the rejection region. This particular test is a one-tailed test, and it's a left-tailed test. Now, how do I know that? The null says that the mean is at least 10,000. So proving that the null is false requires that we get a sample that's low enough that we would reject that null. The rejection region divides the curve into two parts. We have what is called a fail The rejection region divides the curve into two parts, where we have both a fail to reject region and a rejection region. This is a left-tailed test. Next, we need to find the critical values, which mark the boundary between reject and fail to reject. We need a ZC value. Now, since our alpha is 0.01, we want to look up that area on the table because that is the area of the left tail. We need to go to the formula tables for that. So one of the ways that we can look up the ZC is to do it the same way we had done in the past, and that is to find the 0.01 in the body of the table. Okay, right here is 0.0099, that is the closest one. So we can get our negative ZC to be negative 2.33 from that alone. That's one way to do it, where you let the alpha be the area in the tail. There's another option though, which comes from the T table. We have a left-tailed test, so all of our alpha is concentrated in just that one tail. We can now go to the one tail row for alpha and find the 0.01. Certain common ones are going to be on this table, so if our alpha is not on this table, we would have to use another table or use some other technology to find it. But our 0.01 is here, so we want to trace it down. But the question is, how far do you go? Well, remember, this is a case where the population standard deviation is known, and we want a Z, not a T. And if you recall, one thing about T distributions is they become equal to Z distributions when the degrees of freedom is infinity. So we actually want to go all the way down to the bottom for a Z value. Use infinity. So 2.326 would be a good answer here. Let's go back. Okay, so our negative ZC ended up being negative 2.326. We want to now add that number to our picture. And that number is going to go along with our boundary, representing the cutoff between rejection and fail to reject regions. The last part of this is to use the sample mean that we had found to calculate what's called a standardized test statistic. The formula for it is Z star equals our sample mean minus the claimed population mean divided by the standard deviation over the square root of n. For the purposes of the test, we assume that the claim was correct, so we let mu be 10,000. Punch that into calculator, and you get negative 1.19. The question now becomes, where does our sample mean fall on the curve? Is it in the rejection region or the fail to reject region? Well, the boundary, the cutoff, is negative 2.326. Ours is not quite that negative. So we're actually about here. And that puts us in the fail to reject region. So we are going to fail to reject HO. The last thing to do is to write a conclusion about the original claim. The company said that their cartridges would last for 10,000 copies. We found a sample mean that was below that, but it wasn't far enough below it to warrant rejection of their claim. We have to concede the possibility that maybe we just got an unusually low sample mean, but maybe the population mean really is 10,000 or above. Now, before you even decide how to word your answer, it may be helpful to write next to the hypotheses which one you like and which one you don't like. We fail to reject HO, which means that we actually like it. And that means we don't like HA. So whatever you say in your final conclusion, you want it to be in agreement with these. This guide here will help us decide how to word our final conclusion. Now, when HO is the claim and HO is rejected, then naturally we'll say that we reject the claim. However, we have the second case. HO was the claim, but we fail to reject HO. So we have to word it like this. There is insufficient evidence to reject the claim. Here's how I'll write my final conclusion. There is insufficient evidence at the alpha equals 0.01 significance level to reject the manufacturer's claim that the mean lifespan of toner cartridges the manufacturer produces is at least 10,000 copies. So you want to make reference to the significance level because we're not saying that the manufacturer is definitely correct in their claim. We're just saying that with the sample we collected, we don't have enough confidence in them being wrong to refute what they had said.